So today we are covering section 5.1, which is about systems of linear equations in two variables. And applications. So the system of linear equations, what that means, if you have more than two or two or more linear equations is called system of linear equations. And then the example is given in the handout. A solutions to a system of linear equations is an ordered pair. There is a solution to both individual linear equations. So we are going to solve number 1 and 2. We are given a system of equation, and we are given another point here, and we are going to check if the point is a solution for this system of equation. So in order to do that, we have to plug in the x and the y value into the given equation, and then both sides. But we have to check both equations. So I'm going to try the next one. So we're going to check if it is equal to -7. So we get 3 equals -7, which is not true. So 3 cannot be equal to -7. So it doesn't satisfy the second equation. So the answer is no, it's not a solution. So let's take problem number 2. So the first equation has fractions, and the point is 4, 3. So we have to plug in these values into this equation. So let's check the first equation. We have to say if it is equal to 5/6. So we get 4/3 minus 3/6. Is it equal to 5/6? Since the denominator in this side is 6, the least common denominator, I'm going to multiply both numerator and the denominator by 2 to make it equal. So we get 8/6 minus 3/6. Is it equal to 5/6? Since we have the same denominator, we can subtract the numerator. So we are getting 5/6 equals 5/6. Next, we are going to substitute in the second equation. So that gives put the values for y. Y is 3. Is that equals -2 times 4? Yes, we are getting 3 equals -8 plus 11, which is 3. So this one also works. So the answer is yes, it is a solution. The next one, we are going to solve system of equations. We are going to get the solution by using different methods. The first one is the substitution method. So we are solving number 3 from the handout. Solve the system using the substitution method. If the system doesn't have any doesn't have one unique solution, also state that number of solutions and whether the system is inconsistent or consistent. So we have to check all the consistency, inconsistency, dependency, and independency and everything. So let's start writing the equations here. Okay, so we are using substitution method. So what we are going to do, since y is by itself here, I'm going to plug this y into this, for this y. This I'm going to substitute y into the second equation. So what we are going to do, I'm going to replace this y by 13 minus 3x. So distribute the 9. And combine the like terms here. And move the negative, 117 to the other side. So we get negative 25 equals negative 125, and divide by 25 both sides. Negative 25, so we get x equals 5. So now we got the x, we're going to get the y next. So now we have y is 13 minus 3x. So substitute x equals 5 here. So that's going to be y equals 13 minus 3 times 5. So 15. So y is negative 2. So the solution is -2. Since there is at least one solution, the system is consistent. And the equations are independent because they both equations are different equations. Only if both are same, then we get the independent. Next, number 4. Again, solve the system by using substitution method. So from the first equation, get the x by itself. So x is going to be 8 minus 5. So we're going to substitute this x into the second equation. So we are going to substitute x equals 8 minus 5y in 2x plus 6y equal to 16. So I'm going to replace this x by 8 minus 5y and distribute the 2. And combine the like terms now. So what we are getting here, negative 4y equal to 0. When you divide both sides by negative 4, we are getting y equal to 0. Now we're going to get the x value. So substitute y equal to 0 in x equals 8 minus 5y. So we are getting x equals 8. So the solution is 8, 0. And since we have one unique solution, the system is consistent. We have to have at least one solution and the equations are independent. Next, let's do number 5. So we have kind of fraction in the second equation. Just one fraction. Keep writing the y. Minus 4 equal to y. So now we can substitute this y in the first equation. So I have y equals 5 half x minus 4 and plug that one in the first equation. So we get so now distribute the 2. So I get negative 10 over 2x plus 8. Negative 2 times 5 is negative 10. So we get 5x minus 5x plus 8 equal to 0. So 8, and we get 8 equals 8. Or we are getting an identity. That means you have same number on both sides. That means we are going to have infinitely many solutions. Since I have many solutions, this system is consistent. So I can say it's consistent. Whenever you have infinitely many solutions, equations are dependent. What are the infinite many solutions? This means x, and then you can write any one of the equation in the solution. And number 6. So we are seeing example for each one of them. So now substitute the first one into the second. So I'm going to substitute this y, the second one. So 3x minus 3 minus 3x equal to 1. So I'm getting negative 3 equal to 1, which is not true. So this one doesn't have any solution. And even there's no solution, the system is inconsistent. And the equations are independent. Next, we are going to see another method, which is called the addition method. So we're going to solve number 7 using addition method. So in order to do the addition method, we have to bring all the variables to one side. So I'm going to move the 3x to the other side so that becomes positive when you add them. And the second one, align the like terms. Since we are going to add addition or elimination method, we can multiply the first equation by, we can eliminate, you can choose that variable to eliminate. I'm going to eliminate y. So I'm going to multiply the first equation by -9. So this becomes -27x, -9y equal to -117. And write the second equation as it is. So 2x plus 9y equals -8. So when we add them, these two get cancelled. That is called the addition method or the elimination method. And we get -25x equals -125, and divide both sides by -25. So we get x equals 5. So we got the x. Now we can get the y by substituting in any one of the equations. So substitute x equal to 5 in y equals 13 minus 3x. So we get 13 minus 15, which is equal to -2. So the solution is 5, -2. So it's going to be consistent and independent. And same thing with number 8. Let's do that. So we have x plus 3y equal to 27. So we're going to use the addition method here. -4x plus 4y equal to 36. So I'm going to eliminate x here. So I'm going to multiply the first equation by +4. So you have to multiply each term by +4. So that gives 4x plus 12y equals 108. Then write the second equation as it is. So we get 16y equals 144, and divide by 16 both sides. We get y equals 9. So we got the y. Now we can substitute and get the value of x. So we get x plus 3 times 9. So x plus 27 equals 27. So x is going to be 0. So the solution is 0, 9. And since there is one solution, the system is consistent. And of course, it is independent. So number 9, we are going to number 9 and 10 are word problems. So number 9 is Keisha bought 3 large pizzas and 2 orders of garlic bread of $26.75. Donna bought 4 large pizzas and 4 orders of garlic bread for $39. So we're going to choose variables. So let's first define the variables. So I'm going to say x is the cost of large pizza. One large pizza, and y represents cost of 1 garlic bread. So cost of 3 large pizzas plus cost of 2 orders of garlic bread, that equals the total cost. So now we are writing the equations. This equals total cost. So how do I going to write the equations? 3x plus 2y equals 26.75. And same thing with cost of 4 large pizzas plus cost of 4 garlic bread is equal to total cost. So again, that one gives us 4x plus 4y equals $39. So now we are going to solve these equations. So I'm writing the equations again. Equal to 26.75. Now, when you look at the equation, you can tell which variable we can eliminate. I can eliminate y because this is 4 and 2. So I'm going to multiply this by -2. So this gives us -6x minus 4y equals -53.50. And then write the second equation as it is, which is 4x plus 4y equals 39. So when we add, we get -2x equals -14.5. So when we divide by -2, so we are getting 7.25, which is the cost of one large pizza. So now we can get the y. We can substitute in any one of the equations. So I'm going to substitute x equals 7.25 in the first equation. It doesn't matter which equation we choose, we get the same answer. So this is 21.75 plus 2y equals 26.75. Subtract 21.75 both sides. 2y equals 5, so y is 2.5. So the cost of one large pizza is $7.25, and the garlic bread cost of one garlic bread is $2.50. And the last problem we have is the interest problem. So we are going to use the simple interest formula. So the simple interest formula I is P times R times T, where I is the interest amount and P is the principal amount. R is the rate of interest per year, and T is time. Again, this in years too. So in the problem, there are two types of loans. So I'm going to draw a figure, like this is for the first one, and then this is the second one. When you add, you get the interest. So so the first one here, the Erling borrowed a total of 34,000. So the total is going to be 34,000. So we don't know what the amount of the first one. This is the amount of the second one. this is, and the interest for the first account is 0.05, and this is going to be 0.07. And then the total amount interest earned is 1950. So now we are going to add these two. So the first equation is x plus y equal to 34,000. And the second one, you have to multiply this 2. So it's going to be 0.05x plus 0.07y equal to, sorry, we don't have to multiply for the interest. That is equal to 1,950. So now we are going to we can use the substitution method. That's easier. So I'm going to get the x by itself from this equation, which is x equals 34,000 minus y. Now substitute this y, x in second equation. So we get, so I'm going to substitute this x and now distribute. So we get 1700 minus 0.05y, 07y equals 1950. So combine this, we get 0.02y, and then move this to the other side. So we get 0.02y equals 215. So divide both sides by 0.02. So we have to use our calculators here. So y is 12,500. So we can get the x. X is going to be, because the total amount is 34,000. So substitute for y. So we get x equals 21,500. So now we can say Orly borrowed 21,500 at 5% simple interest and 12,500 at 7% simple interest. So that is the end.